Hello and welcome to Design Patterns for Software Developers Intro. Pattern, pattern, pattern. Pattern, by dictionary definition, is a regularity in the world, in human-made design, or in abstract ideas. As such, the elements of a pattern repeat in a predictable manner. A geometric pattern is a kind of a pattern formed of geometric shapes and typically repeated like a wallpaper design. It is also something intended as a guide for making something else, like a blueprint for a house or a pattern for a skirt. But we're not going to talk about patterns on how to make houses, clothes, or geometric shapes. Today, we're going to learn about design pattern in the context of software development, what inspired the Gang of Four, and why we as a software developer or engineer should learn them. We will also discuss the three basic classifications of patterns that are widely used in object-oriented programming languages. So let's get started. Design patterns are like pre-made blueprints that you can customize to solve a recurring design problem in your code. The pattern is not a specific piece of code, but a general concept for solving a particular problem. Patterns are often confused with algorithms because both concepts describe typical solutions to some known problems. While an algorithm always defines a clear set of actions that can achieve some goal, a pattern is a more high-level description of a solution. The code of the same pattern applied to two different programs may be different. An algorithm is like a cooking recipe. Both have clear steps to achieve a goal. On the other hand, a pattern is more like a blueprint. You can see what the result and its features are, but the exact order of implementation is up to you. The concept of patterns was first described by Christopher Alexander in a pattern language, Towns, Buildings, Construction. The book describes a language for designing the urban environment. The units of this language are patterns. They may describe how high windows should be, how many levels a building should have, and how large green areas in a neighborhood are supposed to be, and so on. The idea was picked up by four authors: Eric Gama, John Velicides, Ralph Johnson, and Richard Helm. In 1994, they published Design Patterns, Elements of Reusable Object-Oriented Software, in which they applied the concept of design patterns to programming. The book featured 23 patterns solving various problems of object-oriented design and became bestseller very quickly. Due to its lengthy name, people started to call it the GOF book. The truth is that you might manage to work as a programmer for many years without knowing about a single pattern. A lot of people do just that. Even in that case, though, you might be implementing some patterns without even knowing it. So why would you spend time learning them? Design patterns are a toolkit of tried and tested solutions to common problems in software design. Even if you never encounter these problems, knowing patterns is still useful because it teaches you to solve all sorts of problems using principles of object-oriented design. Design patterns define a common language that you and your teammates can use to communicate more efficiently. You can say, "Oh, just use a singleton for that," and everyone will understand the idea behind your suggestion. No need to explain what a singleton is if you know the pattern and its name. The intricacy, amount of detail, and scope of applicability to the overall system being developed are all factors that differentiate design patterns. Like the analogy to road construction, you can make an intersection safer by either installing some traffic lights or building an entire multi-level interchange with underground passages for pedestrians. The most basic and low-level patterns are often called idioms. They usually apply only to a single programming language. The most universal and high-level patterns are architectural patterns. Developers can implement these patterns in virtually any language. Unlike other patterns, they can be used to design the architecture of an entire application. In addition, all patterns can be categorized by their intent or purpose. The three main groups of patterns are creational patterns, structural patterns, and behavioral patterns. Creational design pattern provides object creation mechanisms that increase flexibility and reuse of existing code. Example patterns are singleton, prototype, builder, abstract factory, and factory method. Structural design pattern explains how to assemble objects and classes into larger structures while keeping these structures flexible and efficient. Structural design patterns are adapter, decorator, bridge, flyweight, proxy, facade, and composite. Behavioral design patterns are concerned with algorithms and the assignment of responsibilities between objects, such as chain of responsibility, command, iterator, visitor, state, strategy, observer, template method, mediator, and memento. Today we learned what a design pattern is and how it will help us as a software developer. We also learned the three classifications of design patterns such as creational, structural, and behavioral patterns. As part of our design pattern series, on the next video, we're going to go in detail in each creational design patterns. So stay tuned by clicking that subscribe button to notify you once it's ready. Thank you for watching. Until next time, happy coding!